In level 2, we will be evaluating inverse trig functions, which is going to be really similar to level 1, where you're finding a missing angle given the value of a trig function. But specifically talking about inverse trig functions, like the inverses we learned about last semester, they are only defined over a certain region. If you remember, for a function to have an inverse, it had to be a one-to-one function, meaning it had to pass the horizontal line test. And looking at sine, cosine, and tangents graphs, none of them pass the horizontal line test. So what we do to take the inverse of these functions is we only look at a certain section of the graph. For a sine graph, we look at the interval from negative pi over 2 to pi over 2, and if we just take that section of the graph, that little part is one-to-one, and I could find the inverse of that part. So the range of sine inverse is going to be from negative pi over 2 to pi over 2. For cosine, same thing. It's not one-to-one, so we're only going to look at a certain section of it, and we're going to look at the cosine graph from 0 to pi, and that little section by itself is one-to-one, so I can find its inverse. So when we look at inverse cosine functions, its range is going to be from 0 to pi. And then for tangent, we're going to look at just one period of a tangent graph, or one little section, so between the two asymptotes from negative pi over 2 to pi over 2. So the range of a sine and a tangent graph are going to be negative pi over 2 to pi over 2. A cosine graph is going to be 0 to pi. So when we evaluate inverse trig functions for sine and tangent, on our unit circle, we are going to look from pi over 2, well, negative pi over 2, to pi over 2. So only this section of the graph. And we could fill in the rest of this half of the unit circle. This would be 0, pi over 6, pi over 4, pi over 3, and then the negative angles down here, negative pi over 6, negative pi over 4, negative pi over 3. We can fill in our ordered pairs if we want to, just to make this complete. This is 1, 0, radical 3 over 2, 1 half, radical 2 over 2, radical 2 over 2, 1 half, radical 3 over 2, and 0, 1. And down here in quadrant 4, we have negative y values, but still positive x values. So this is radical 3 over 2, negative 1 half, radical 2 over 2, negative radical 2 over 2, 1 half, negative radical 3 over 2, and 0, negative 1. Then for cosine inverse, we are only going to look at a range of 0 to pi, which is going to be the top half of our unit circle. All positive angle values this time, so we would have pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, and 5 pi over 6 would be the angles. And then you can go ahead and fill in your ordered pairs too. And there are your coordinates. So just to recap, whenever you are evaluating inverse trig functions for sine or tangent, we're looking at half of the unit circle, but from negative pi over 2 to pi over 2. So half our angles are negative, the other half positive. And it kind of makes a D shape, like this. And with a cosine, it's the top half of the unit circle that we'll be looking at. Now to evaluate our inverse trig functions for sine inverse and tangent inverse, which we sometimes call arcsine and arctangent. Those mean the exact same thing as sine inverse and tangent inverse. We're going to be looking at this D-shaped part of the unit circle. And then for cosine inverse, which we can also call arc cosine, we look at the top half of the unit circle from 0 to pi. So for sine inverse of radical 2 over 2, I want to find the part of the unit circle, or between negative pi over 2 and pi over 2, where we have a sine value of negative radical 2, and that happens right here at negative pi over 4. And that is the only place that it happens. So when you evaluate an inverse trig function, it only has one angle that works, or one answer. For cosine inverse of 0, now I'm looking at my 0 to pi on the unit circle, and the only place that has a cosine or an x value of 0 is pi over 2. And for the next example, arctangent, which means inverse tangent of radical 3 over 3, that's going to be, you get radical 3 over 3 by dividing 1/2 by radical 3 over 2. And so we want a y value of 1/2, an x value of radical 3 over 2, and positive tangent values. So we're going to be looking in quadrant 1, and we get pi over 6. In the next part, we're doing just some multi-step evaluating, so combining some of our regular evaluating the regular functions with evaluating inverse functions. In part D, first I would find cosine of pi over 3. Cosine of pi over 3 is 1/2, and then I'm going to do cosine inverse of 1/2. So now I'm asking myself which angle has a cosine value of 1/2, and that is pi over 3. In the next example, first I'm going to do tangent of 2 pi over 3. Tangent of 2 pi over 3 is negative radical 3 over 2 divided by 1/2, which gives us negative radical 3. Now I'm going to do tangent inverse of negative radical 3, so I need to look between negative pi over 2 and pi over 2 and find the place that has, or the angle that has a tangent value of negative radical 3. Tangent values are negative in quadrant 4, and so the answer is going to be negative pi over 3. And for our last example, first we start on the inside and we evaluate sine of pi over 6. Sine of pi over 6 is 1/2. And now I'm going to multiply radical 3 times 1/2, and I get radical 3 over 2. Next I'm doing arc cosine, or inverse cosine, of radical 3 over 2. So I need to look at the top half of my unit circle, where do I have a cosine or an x-coordinate of radical 3 over 2, and that is at pi over 6.